Today we set sail into navigating radical axis, a compass guiding us through the geometric seas, revealing hidden treasures within circles and shapes. Join us as we immerse ourselves in this mathematical expedition. Now get your maps and let's begin the voyage!
We've reached our first island. Looks like we'll be clarifying some key terms. The radical axis, also called the radical line, is the locus of points with equal power with respect to two circles. It is the line where the tangents drawn to the two circles are equal in length. Awesome facts, right? Come on, crew! We still have a lengthy journey ahead of us. Now, let's revisit the standard equation of a circle. X minus h squared plus y minus k squared is equal to r squared. In the context of radical axis, we encounter orthogonality, meaning the radical axis is perpendicular to the line connecting the centers of the circles. This relationship is crucial for understanding the geometry and power properties of circles and their radical axis. I can see that you're all geared up. How about we put what we've learned so far into practice with these sample problems before checking out the awesome treasures inside? You can do it, crew!
And two non-concentric circles with the equations x squared plus y squared plus 4x minus 10y minus 20 equals 0, and x squared plus y squared plus 6x minus 8y plus 30 equals 0, find the equation of the radical axis. To tackle this problem, we need a systematic approach. First, label each equation as S1 and S2 respectively. Then arrange them into the formula S1 minus S2 equals 0. This yields an equation structured like this. We chose to put the equation in parentheses to later distribute the negative sign and perform the needed operations. You may try this as well to avoid confusion.
With your equation set, we can proceed to solve or cancel like terms, which are those with the same variable and degree, by distributing the negative sign to each term within the parentheses. Consequently, x squared and y squared terms will cancel out, resulting in negative 2x minus 2y minus 50 is equal to 0. Sometimes, the resulting equation may be negative, but a positive equation is preferred. To ensure the final equation for the radical axis is positive, we can multiply it by negative 1.
The equation of the radical axis of two given non-concentric circles would be 2x plus 2y plus 50 equals 0. Were you able to follow through? Great! Now we'll leave you with a sample problem to test yourself further. You can now get to your treasures. Carry on, crew!